Hi everybody, and welcome back to Around the Shack. In this episode, we're going to go ahead and take a look at this Heathkit VTVM model IM-11. I'm going to go ahead and try and give this thing a little bit of a restoration. Picked it up recently from a local person. This thing has been sitting in their garage for a very long time, was covered in a lot of dust, but overall, it's in extremely good condition. Hardly anything wrong with the chassis at all. And since this is going to be just my personal VTVM for radio restorations and whatnot, I am not worried about a little ding here or a little ding there. So we're going to go ahead and tear into this thing here and see what is going on with it. I'll be honest with you, I've already kind of taken a little peek at it to see what was inside. All of the controls here seem to be turning and working, which was a really good thing. This plastic cover here is a little bit yellowed. It's scuffed, but nothing that some new tone can't take care of. Pop that off and clean that up and hopefully make it like new. I've already taken the 2 screws out. And the nice thing here too is that the cord is in actually really good condition. It's still very flexible. So I'll just clean that up and I'll clean these contacts up. And I'll be honest with you, I'm not going to change it because I don't have to worry about hot and neutral with this model VTVM, because as you can see right here in the schematic that I'll put up in just the power supply section right here, that this model has effectively a isolation transformer built right into it. So the line coming in, it doesn't matter if it's hot or neutral, we'll go through the primary of the the transformer for the power supply and then right back out again. And this thing's worked for years and years and years like that, and there's no hazard shock or anything like that. Because it has its own isolation transformer. So I'm just going to keep it as is, the way it is. So on the inside, you can see it just pops right up. Once those screws are out, the whole case just slides right off. And the inside was in very good condition. So let me go ahead and take the cord out. And here we are. Here's the inside of this. I've already taken the battery out. Somebody had already been in there and taken out and replaced the battery because there was a nice little Duracell in there. So I'll bring some light in here, make it a little bit better. So it's got the 2 tubes in here. And obviously this is the power supply. So obviously the first thing I'm going to do is go in here and replace the electrolytic capacitor right here. That's part of the supply. The selenium rectifier, I believe, will be just fine the way it is. If it causes problems down the road, then I will know where the problem is. I'm going to go ahead and check all the resistors. And then there is a waxy cap way down here. I don't know if you can see it here. You might have to break out the flashlight here, but right underneath there, and I'll get a better shot of it in the future here. Yeah, sorry about that. You can't see it because it's dark. Yeah, you can't see it. But anyway, there's a small value waxy cap, but it's high voltage, and that is the on the schematic. That's the capacitor for the AC volts measurement, because on AC we can do up to 1500 volts of AC. So that's what that capacitor is, and that's why it has such a high voltage. So definitely one thing I have to do here is you can see how black and tarnished these connectors are right here. This contact switch is just absolutely black. So I'm going to go ahead and clean that up, make it shine like brand new. And when we get to that point, I'll show you how I do that. Somebody has tied these down with what are those? Those are pipe cleaners. And actually, that is very sharp right there. So I'm going to be getting rid of those and using some standard zip ties, and go through, test all these resistors out, replace what needs to be replaced, and get this thing going, calibrate it when it's all said and done. And I'll have myself a meter here that you and I can enjoy for a long time to come for restoring radios, and who knows what else this thing will be used for. So let's go ahead and get to it. I'm going to go ahead and set up the bench, get this thing ready, and go ahead and tear into it. Okay, one thing before I get started on all this stuff is I wanted to hook this thing up to a variable power supply, the variac and the dim bulb tester, and power it up so we can at least see, you know, is it worth, or how bad is it, whatnot. So I'm going to go ahead and just kind of move my camera here really quick. This is my dim bulb tester. I actually did a video on that. Where am I at here? This is upside down and backwards. Sorry about that. So did a video on this right here, and this thing works great. So the Heathkit is plugged into this. The variac is right there, and it's set right now to about 60 volts. So we'll go ahead and turn on the, sorry it's sideways, but I have an overhead mount camera here, so so you can see what's going on right there. And we'll go ahead and turn this thing on at about 60 volts right now. So I'm just going to turn this thing on to DC plus. I'm looking at the bulb right now, and there's no problems with that at all. I can't even tell if the bulb is doing anything. So that's actually a good sign, because if this thing was shorting out or had any kind of problems to it, the light bulb would light up. So far so good. Nothing's going on here. 60 volts. Let's go ahead and crank this up to about 90. See if we can get any tubes coming up. While we're waiting for the tubes to warm up here, I would like to say that if you are following along with any of these videos, especially ones like this with these old units, especially tubes, equipment, tube radio, TVs, test equipment, anything like that, they have very high voltages in them. So if you don't know what you're doing and you're following along with these videos, you're doing so at your own risk. I think I'm starting to see a little bit of filament, no smoke, so that's a good sign. So let's go ahead and bring this thing up to full voltage, which is 120 on the variac. And oh yes, I can see the, let me turn this light off. Yeah, tubes. The soft, beautiful glow of tubes. See those wonderful filaments lighting up. So that's a good sign. Oh yes, okay. And here we have on the front, the meter is deflecting, which is good. So the one thing about here, I do the zero adjust on DC plus and minus, and it will actually zero. It's got some good deflection towards the positive side and towards the negative. There's also some room. So if I zero it here, go to minus, the zero adjust is backwards now, so going counterclockwise makes it go up. But it's the same thing. It's got a lot of good deflection, both directions. So if you were, say, turned this on and the meter was way up here, and this zero adjust was almost like right there. Let's say you were turning it counterclockwise and it stopped right there. It's as far as you can go. And this is as far as the meter would go down. That means something is wrong with the bridge. And then you'll have to go in and start troubleshooting that. But luckily this one here, we got good deflection, both plus and minus. So and I can't do anything with ohms because there's no battery in it. So okay, that's a very good sign. Let's go ahead And I'm going to power it down, and let's start tearing into this thing here. And I think the first thing I'm going to do is change this capacitor right here. Okay, all right, see you in a bit. Okay, I'm back, and before I change this capacitor right here, I just wanted to show you a little something that's going on here with the cleaning of this right here. So if you look at this, how black this is right here, just tarnished from years of who knows what. Like I said, it was sitting in this guy's garage for obviously years and years and years, so I don't know the condition. Could be a lot of humidity, I don't know what. But if you look right here, I've done two things, did an experiment. I've used deoxit on one, and this is not a promotion or an anti-promotion or anything like that for deoxit. This is just what I use. It works great. In fact, I'm going to spray all the connectors in here when I'm done, and all the rheostats and potentiometers, if you want to call them that. But this section here, if you look at it, try to get a good shot here in the video. There we go. This section right here, I sprayed with deoxit. Okay, let it soak, and then I gave it a little scrub with the Q-tip. You can see right here the Q-tip is a little dirty right there. This little shiny spot right here, I gave a dab of good old-fashioned Tarnex, which I've been using for years on electronics, and it works great. If you look at the difference, the comparison here, this here was, and this was really stubborn, I had to do this twice, put a little Tarnex on there and let it sit for 5 minutes. Gave it a little scrub and it shined right up. Put some more on there, let it sit for 5 minutes, and gave it a little scrub, and look at that, how clean that is right there. Now deoxit did clean this right here, so it is doing what it's supposed to, but deoxit is not designed to take off this much tarnish. This is just, in my opinion, record breaking. It's the worst I think I've ever seen. So really quick here, I just want to go through and show you just how resistive this stuff can be. Right here is where I did the tarnish. And if you look at the meter there, it's saying 2 ohms. Well, that's what my leads are, 2 ohms. If you go here where the tarnish is still, but the deoxit did, that's showing 5 ohms. You know, but if I scrape it around a little bit like a connector would, it's still 2 ohms. If I come over here to this connector, that's showing 19 ohms. So that's going from here to here through all this tarnish, you know. Down here, which it's really bad on this one for some reason, you know, it's showing very high in certain spots but low on others. And this is the main power connector here too. You know, look at that. It's so high over here that it's 200 ohms, 100 ohms, 45, depends upon where I scrape it. You know, look at that, 50 ohms basically. So this has got a lot of resistance to it. But yet you come up here where the Tarnex is, and it's a beautiful 0 ohms. Remember, my meter is showing 2 ohms for the cable resistance. So I just wanted to show you that. I'm going to give this a quick clean. Well, it's not going to be quick because I got to get in there and let each one of these sit, move it around a little bit. Then once I do a Tarnex on everything in here, I'm going to go ahead and put deoxit cleaner on all of the switches right here and right here, and then I'm going to clean the potentiometers for the adjustments here and for the 0 out, which is down here. Then I'm going to go ahead and change out. Let's see, I actually brought a flashlight this time. Look at that. See, there's that waxy in there. And I could show it on the schematic. It's a .047 at 1500 volts. So, and there's my kitty. There's Sammy. He's come up here to make sure that I do everything right. And then I'm going to change this capacitor. So I'll be back in just a few. Okay, well, I'm in the process of changing out that capacitor. There it is right there, right there. So, and that's this capacitor right here for the AC input, 1500 volts. And I've started cleaning. If you notice here, I'm trying to use a flashlight. Now you can see those rings right there, right down the middle of the shaft. There's a ring around there, and basically they're right here and right here. I'm trying to use a flashlight because it's really dark in there, but they're nice and shiny now. So had to pull the whole assembly apart. That's the only way to get in there. And then right here, I've dabbed on some Tarnex about 5 minutes ago. And it's just been kind of sitting there and soaking, and I'm going to do the same thing with this right here. So I just wanted to show you that, you know, just put on a little Tarnex and you know, give it a little rub, and you can already see that just by doing that, it starts to come a whole lot cleaner. Now this one here is really, really bad. I'm probably going to have to do this several times to get that to work. So anyway, capacitor here is replaced. I'm going to change this out. I'm going to put a BNC connector in here, so it'll be like this when it's done. Okay, because most probes and everything like that nowadays, they're all BNC, and so I just want to get rid of this 1/4 inch jack right here. So that's where I'm at. I'll come back. I'll show you how clean everything is. I've already ohmed everything out, started ohming out resistors, and things are looking good so far. So just thought I'd give you an update. See you in a few. Okay, I'm back, and I figured I'd give you a little update on what's going on here. I've spent a lot of time cleaning everything, even cleaned the cord here. Got all the goo, sanded this down. This was just caked with goo and grime. I had to use soap and water and a toothbrush to get in there and clean this cord out. So that's all nice and clean now. All of these leads here are cleaned up. If you remember how black these were before, they are a lot better now. I'm not sure what's going on with the discoloration here. I'm suspecting that my Tarnex that I put in here might be slightly on the old side. This bottle I've had, this thing's got to be pushing 10 years old. So I went and ordered another bottle. But to show you what's going on with the cleaning, if you look at the meter here, it's registering around 1 ohm for the lead resistance. And if I just go here and connect to those two, this is the unit is on. It's showing 0 ohms. So no matter where I show it, click it on here, it's going down to 0.6. Go move it over here. So there's, no matter where I put my probe, this here is showing perfect continuity, and the same for up here as well. So Tarnex did a great job. Once I cleaned everything and scrubbed it off with the Tarnex, I sprayed everything with a deoxit a couple of times to clean everything off. I went in and I got the capacitor in here, which you should be able to see, that yellow capacitor right there, has been replaced with a 0.047, like the one shown here in the schematic. That's been replaced. Every single one of these, like I showed you in the previous little clip there, that this all had to get taken apart to be able to get up underneath and clean underneath each one of these things here with a Q-tip and some Tarnex. So that actually took a couple of hours worth of work to do that. Sprayed some deoxit in each one of these calibration potentiometers right here, and cleaned off the zero adjusts and the ohms adjust. potentiometers as well. Changed the capacitor. It was a 16 at 150 volts, and now the capacitor is a 0.22, which is only a 20% increase. So, and with tube equipment, that's okay. You never really want to go more than double for values like this. I probably could have gone up to 33 microfarad, but this is 160 volts at 22 microfarads. So that's been replaced. In order to get in there and clean everything out, or change the capacitor first of all, do have to take these two screws out that mount the PCB to the meter. So these have to come out, and then the board just kind of lifts right up, and that gave me enough room to get underneath here to desolder the old capacitor and put the new one in there. And since I had the board kind of lifted up and it was floating around a little bit, with these both lifted up and out, things could move around a little bit. I actually just went in with the meter and started testing resistors. So everything showed that it was within tolerance, and so I was pretty happy about that. You know, went in and basically looked at each one of these. Since there's these are tubes, there's nothing pulling the resistors down, and any of the resistors that were pulled down, I just checked them out to make sure that they were within their specifications. So the resistors looked good, the potentiometers have been cleaned, the switches have been cleaned, the capacitor's been changed. So now I think we're getting to the point where I can go ahead and power this thing up and do a calibration on it. I might go ahead and before I do that, give this thing here a little cleaning with some of this what I call it here. I call it E-tone or something like that. So it's called Novus. That's what it is. It's called Novus, and I picked some of that up from some recommendations on some other YouTube videos on how to clean those up, because I could have just gone and picked up some windshield headlight cleaner. I'm sure that would have worked. I saw a lot of videos on those too, but this stuff here, I got it off of Amazon for like $10, so I was pretty happy with that, and I'll give that a try, and then we'll come back here and I'm going to fire this thing up. We'll do a calibration, and hopefully this thing will be just the way I need it, because it's going to sit right there on the bench, and then we're going to go ahead and start working on some what am I going to do next. It'll be a surprise. Stay tuned, we'll figure it out. Probably be a radio or a function generator, one of the two. So this thing is looking good. The BNC connector is hooked up, so now I can I'm not going to worry about the quarter-inch jack anymore. I can just take a standard set of probes, plug in the BNC, and use anything I want. Don't have to worry about being stuck with that big bulky probe. And I will also be modifying the probe to accommodate the BNC. So things are looking good. All the connections are great. 0 ohms all the way around. I'm very happy with the way this thing has turned out. So on the next shot, we'll go ahead and set this thing up for calibration and a power up. Okay, so I'm all finished with just about everything now. I want to go through and do a few adjustments and show you how those are done. It was kind of funny. I could not find a decent... I have every battery known to mankind around here except a C battery. And this one here was from a flashlight, and it's only got like 0.8 volts on it, so it doesn't work very well. So I kludged in a AA battery with a little piece of aluminum foil right there and tested it out, and it gets the job done for the purposes of this demonstration. Ignore the flickering on that. I substituted out the standard, I think it's a number 50 bulb, and I put in an LED. So because this is an AC line right here, this LED is acting as a half-wave rectifier, and so that's why it's flickering. So just ignore that, but it comes across very nice. I like it. It's like a 100 ohm or 68 ohm resistor in there, not heating up, doesn't get warm at all, and works very, very well. Okay, so if you look at the instructions right here about ohms check and calibrate, this is the calibrate page right here basically. This first part here, you can pretty much, follow it. Basically just says turn it off, put the battery in, turn it back on again. And then you just need to go in and set the function switch to ohms, which it already is. This has been sitting here for a while warming up. I recommend at least 5-10 minutes before you're actually going to start using the device. And then it says switch the probe to ohms, which I don't have a probe. If you look here, I am just using, because remember I switched over to the BNC connector here, so now my probe consists of this right here, a little coax cable with a couple of clip leads on it, or whatever I want. I can put a probe on here or anything I want. Right now I just have this. So having this straight through is essentially the same thing as having the probe set to AC or ohms. It's just straight through. Then the next thing it says is set it to open infinity. That means nothing is connected here, which is what it is. And then do an ohms adjust until it says it's set at the infinity mark, which is the very last mark on the very top right here. What they don't tell you, for some reason, and I don't know why, it does say touch the probe to common, and the pointer should drop back to 0. But then they don't tell you what to do after that. It's kind of like aligning an IF section. If you notice, even on the camera, it did not go back to 0. So it's one of the downsides of one of these meters here. Excuse me, is you have to kind of like with the first IF stage, you got to go 1, 2, 3, 4, get them all peaked out as best you can, and then go back 1, 2, 3, 4. Do that a couple of times. So now you zero this out, and then you open it up. Oh, look at that, see? And went up, and you infinity, short it back. That's not too bad. That's only off by a small. And open it up, and that says almost infinity. Touch it just a little bit, and there we go. So you're just going infinity back, and then you're causing the meter to be at its maximum and minimum. So 0 ohms and infinity. Sometimes it might be like this, and you have to adjust the ohms, and then you short it out, and then you have to adjust this, and which maybe will bring this up a little bit, and then you open it up, and then ohms adjust it this way. So you just got to keep doing that until you get infinity on one side and 0 on the other side. I don't know why they don't say that in the instructions, but that's the way it is. So now we're at infinity. I'm going to grab a red orange, which is a nice 22K resistor, and if you look right there, it is pointing at almost 2.5. So that's pretty darn good. I'm happy with that. Here's a 33K. Come up here, and I'm looking straight on. You probably can't tell from the camera because there's a little bit of a parallax, but I'm looking straight on, and that is pretty much right at 33. So that tells me that the ohms adjustment works, and that the ohms section of this whole thing works just fine. Excuse me. So we're going to go ahead and I'm going to turn the camera off, set this thing up for the DC calibrate and then the AC calibrate, and then we'll be done. I'll put it back together and put it up on the shelf. I'm going to take the battery out right now because, to be honest with you, I will probably never use this for measuring resistance, and I don't want it sitting up on my shelf and come back 10 years later and open it up and have the battery all corroded and everything like that. So I'm not going to put a battery in it. I'm just going to, that's why I just kludged in that AA battery. So anyway, go ahead and turn it off, and I'll be right back. Okay, so now we're back for the next step, which is going to be to do a DC calibration. For the DC calibration here, you'll notice that the meter, and I'll show that up here as well, needs to go through a 1 meg ohm resistor for the DC section. And since I'm just using my newfound BNC connector with a straight through cable, I've gone ahead and added in a 1 meg ohm resistor. I went through my selection of 1 meg ohms, and this one here is like 1.003 meg ohms, so I'm perfectly happy with that. Here's my little power supply, a 1.5 volt battery. Going through the DC calibrate. It talks about, plug the probe in, turn it on to DC, which enables the 1 meg ohm. Connect the probe to common test leads to a newly purchased flashlight battery, and adjust the DC calibrate, that's on the back side inside, so that the meter pointer falls directly over the very small red dot. That would be, you probably can't see it, but there's a little red dot right after the 15 on the DC volt scale right there, the second line down. There's a little red dot. The reason they have you go over there is because typically a brand new battery is slightly more than 1.5 volts. In fact, this is a brand new battery here, and it measures at 1.56 volts, so it's definitely over 1.5 volts, and that's why they have you do it. So approaching the red dot, turning the screwdriver on the control in the back, as soon as it reaches 1.4 volts, and then slow down. Okay, as soon as the red dot is reached, stop turning the DC calibrate. And remember, the range switch must be set on 1.5 volts, which it is. So I'm on DC plus 1.5. This thing has been on for probably 20 minutes now, so it's all nice and warmed up. And what we're going to do here is I have it zeroed out. Here's the meter. Again, why they don't tell you to do this, maybe it's in another part, is short the leads out. There's my meter saying, don't forget about me. Zero the leads, short them out. Do a 0 ohm, a 0 adjust here so that it's right on the 0. And then it might start reading a little bit, but it's just like your digital meter when it's not hooked up to anything, right? It's just sitting there fluctuating back and forth because it's picking up spurious electrons here and there. Same thing here. I can make it move by just waving it around, so that's where it's at right now. So now I'm going to go through a 1 meg ohm resistor into the positive side of the battery, and then hook up the negative to here, and it is not anywhere near. So what we need to do to calibrate this is go to the back, and back here is, get my screwdriver, right here in the center is the DC calibrate potentiometer, and that's what they're talking about. So I'm going to be turning it just like this in the back. So let's get this set back up again. You'll notice it's not reading 1.5. So come back here. Be careful with the screwdriver because there's some voltage back here. And then I'm going to turn the potentiometer until it reads just at just a little over 1.5. Okay. So now, if I go to the 10 volt scale, I think I still need to adjust it some more here. Yeah, it should be reading. Plastic has some static on it. Okay, so let's go ahead and make sure this is zeroed out. trying to look at the scale straight on here. And that's just 1.5 right there. Cable's coming off there. There we go. Okay, 1.5 volts. Come up here. We are going to come back over here, connect that to 0, move the meter to 0. Hook it back up to my voltage, and it's reading, you probably can't tell the difference there, but it's reading 1.5 volts on the times 10 scale right there. So, and that's really all there is to calibrating the DC. So plus and minus should be the same thing. If I click it over to DC minus and just basically reverse the leads, I'm getting, oh, I gotta zero it out here first. Hold on. It up backwards, and we're at 1.5. So let me come up here, and we're at 1.5. So I'm a happy camper with that. The thing I might do is, since this is my own personal bench supply, I have just a straight through cable here. If the probe for this did come with it, it's floating around here somewhere, but I'll be honest with you again, I'm probably never going to use it. Is this 1 megohm resistor works only on DC. It's only in line when it's on DC. And then these connectors here, the function switch right here, has only a DC plus and a DC minus where the 1 megohm resistor is enabled, right? I've done a little bit of tinkering. I believe, where is my non-conductive pointer? Right here. I've done some measurements, and this wire right here that goes from here to here, which is taps into the 7 megohm resistor here, I believe that is a potential for replace this wire and put the 1 megohm resistor in there. That way, I can use just a straight through probe all the time. If I do use DC plus or minus, the 1 meg will always be in line. I can use a straight through probe all the time because, again, I won't be using that big honky probe that comes with the VTVM, because this is going to be used mostly for aligning radios and things like that, where I need that analog meter for the aligning the RF and the IF stages. So I'll let you know how that goes. So next, I'll set this up. We'll do a quick AC alignment, put it all back together, and then we'll be done. Okay, we're back, and what we're going to do here is the final stage of the AC alignment. This should go quick. It's not too terribly difficult. I've made a couple of connections here with the meter, and I'm hooked up to my variac, dim bulb tester, and isolation transformer for the output that we're going to be calibrating it with here. So just keep that in mind. So let's get the camera adjusted here and go through the instructions here. So the first part here basically says plug it in, turn it on, and disconnect the main front jack, which is this right here. So this is disconnected. Set the rating switch to 1.5 volts. Adjust the zero the meter out there, and the function switch to AC, which it is. Now, Also, this has been on for several hours now, so it's nice and toasty warm. Adjust the AC balance control so that no movement is detected when switching from AC through DC minus to DC plus. So that's what we'll do right now. The AC cal is this pot right there in the back. And that's the one I'm going to be turning. So the first thing you want to do is, I'm looking straight on. Okay, so I'm going to zero this out, which was actually pretty close. And switch between AC and DC. See how wide that swings. So come back here and be very, very careful. If you're following along, please be very careful, and you're also doing so at your own risk. There's a lot of high voltage back here, line voltage, so please be careful. So I'm going to go ahead and I'm just going to keep adjusting this and being very, very careful with the with this metal screwdriver back there. Even though in this general area there's not a lot of voltage, so I'm pretty safe because most of the voltage, the high voltage, is over here, the line voltage. There we go. Yep, just going to keep going between 0 . Try to get that to 0. Switch to AC, DC. So you see there's still movement there. And what we want to do is, like the instructions said, adjust this AC balance so there's not a lot of difference between switching between AC and DC. So we're getting there, slowly but surely. And since I'm going to be using this for AC most of the time anyway, let's turn that back. Probably past the adjustment point there. There we go. Oh, yep. Just going to put that on 0. See, the goal here is to have a very small deflection. There we go. Doesn't have to be at 0, just a small, very minimal deflection when switching between AC and DC. Okay, there it is, just like that. So that's the AC balance. Okay, set this up here. The next is So now set the range switch to 150 volts. That's this down here. So we'll go up here, 1, 2, 3, 150 volts. We'll plug in the probe. Remember that this is a straight through probe here because we're on the AC. So if you look right here, you'll see that the AC section is just straight through. Now here's where you need to be careful. Set the range switch to 150 volts and the function switch to AC, which it already is. Reinsert the phone plug, or in my case the BNC, and connect the test probe set on the AC to the common lead across the 117 volt line. So basically they're telling you to take the probe and plug it into the wall socket. And normally that would be a fairly dangerous thing to do. But the nice thing here is if you see the power supply right here, it is its own isolation power supply, own isolation transformer. And the fact that, if you remember, I showed you that this is hooked up to the isolation transformer for this right here, which is an extension cord with a connector on it, an AC connector on it. And I'm going through the variac and through this isolation transformer right here. So I'm double isolation transformered, if you will. That's some pretty bad grammar, but it gets the job done, gets the message across. So what we're going to do now is I'm going to turn on the power, and we should be at 120-ish volts. Let that settle down. I'll tap this variac here a little bit, see if we can't get down to 120, 120.1. That's pretty close, and that's a good representation of line voltage. Now, what we want to do is set the AC calibration, which is this connector right, or this pot right here. AC cal is right there, and we just want to set this to read 120 volts. Okay, now you want to be careful here. I just kind of ride this along this this resistor right here, and then it slides right down in there. So let's go ahead and adjust this to read 120 volts, which is this scale right there. So 150 would be the 15. So I'm going to look at this straight on. And there it is, just like that, 120 volts. You can check this out by going to the 500 volt scale. Okay, got a little bit of static there. Make sure we're still balanced. Yep, that came out a little bit. Yep, 120 volts. And I'll check this. I'm going to turn this down. If you watch the meter there, I'll just go down to 50 volts. I just want to make sure everything's right. Because again, I'm going to be using this for IF alignments on old tube radios. And I just want everything to work and be fairly accurate because it's going to go up in the bench here. The next scene after this will be it all put together and sitting on the bench and working. So there's 50 volt. Look at that, right on the button, 50 volts. I can take this to the 50 volt scale, and it should go to, oh, you know what I forgot to do? Zero out the meter. And recalibrate. Yes, always zero your meter first before you calibrate. Looking straight on. There's 50 volts right there. Come back here. That's reading 50 right on the nose. Turn this back up to 120. $16, $17, $18, 120.5. 2, and we're reading 121. That's pretty close. I like that. I'll take it. And there we are. So that's how you calibrate and refurbish a Heathkit VTVM model IM-11. I'll come right back here in just a few seconds, and I'll have it put in the case and put back together and up on the bench, and then we'll go ahead and close out this video. Okay, well, there we have it. The restoration project of the Heathkit VTVM model IM-11. I hope you enjoyed this video. I know I enjoyed doing all the refurbishments here and customizing it for myself using the BNC connector, which is going to be very handy. This thing is going to get used a lot. You're going to see it in the future on a lot of the videos that are coming down the line, especially the ones for the All-Star radios and stuff like that. Now, my kitty cat's distracting me. He's getting ready to jump up here, so you'll see him. Here's some of the parts that came out. The electrolytic capacitor, the bypass capacitor for the AC coupling, and there he is. There's the original 1/4-inch jack connector. This one here was somebody put in, made out of cardboard, a spacer for the motherboard. I took this out and put in some washers as spacers. These 3 resistors right here came out of the bridge circuit, which I couldn't really test them very well in circuit because they were forming a like I'd have to use a Thevenin calculator to figure these things out. Once I started lifting a leg, these things here were well outside 10% tolerance, so I replaced those with some new resistors. And this here is a little bit of color plastic that used to go right here because of the incandescent light bulb that was back there. I took that out and replaced it with an LED, which looks really nice. That glows really good. So there's the video. Hope you enjoyed it. Again, this thing's going to get used a lot. And so don't forget to subscribe, hit the like button, hit the bell button to get reminders of upcoming videos, and thank you very much for watching. Say goodbye, Sammy. Say goodbye, Sammy. Bye, everybody.